Today we're covering 7th grade, Chapter 7, Lesson 1, Equations and Inequalities. And if you have a textbook at home, this is page 503 to 510. An equation, it kind of sounds like this. Equation sounds like an equal sign. So stating that two quantities are equal. An equation is stating that two quantities are equal. For example, 3 plus 5 equals 8. 3 plus 5 is the same as 8. Or 3 times x plus 5 equals 17. That is also an equation. It has an operation, the plus sign, and it has an equal sign. That makes it an equation. The solution is the value that makes the equation true. And for today, we're just going to do some guess and check to see which solution might make this true. We're going to try 2, 3, and 4. So those are just random numbers, and we're going to plug them in where the x was and try to solve the equation. So first we have to remember to do multiplication. Remember order of operation. So 3 times 2 is 6, and 6 plus 5 would be 11, which is not 17, so that's not going to work. The next one is 3 times 3, which is 9. Plus 5 makes 14, which is not 17, so that doesn't work either. And last one, 3 times 4 is 12, and 12 plus 5 is 17. So that one did work. The solution is x equals 4. Equivalent equation. That's two equations with the same solution. So for example, we know that this first equation has to be solved with 4, and this other equation over here, 3 times what would get me 12? Well, it would have to be 4, so x would have to be 4. Those equations are equal. So you might write that like 3x plus 5 is equal to 3x. Those are equivalent equations. Equivalent means equal. Now let's talk about inequalities. Inequalities, and you probably know inequalities means they're not equal. Inequalities. Inequalities compares quantities, and we use these symbols down here. So this symbol up here, alligator pointing to the left, is less than, or sometimes they say fewer than. The next one, the alligator's pointing the other direction, that would be greater than or more than. The next one, the alligator's pointing to the left, but it also has a line underneath it. That line means that it could also be equal. So we say that as less than or equal to. Or sometimes in a word problem, it'll read more like no more than. No more than. And then the next one, the alligator's pointing to the right, and there is a line underneath it, so that's going to be greater than or equal to or no less than. Like, he can spend no less than $50. He can spend no more than $50. Let's look at some extra examples so you can see what you're going to be doing today. Number 1 here says determine the solution of each equation from the list given. So this is like what you're going to be doing independently. They give you an equation, and you're going to plug in the numbers to see which ones work. So let's start with plugging in a 4, where the variable is. The variable is the p. So this would be 4 times 4, which is 16. And 16 minus 10 would be 6. So that one works. But I'd still like for you to check the other solutions just to make sure that there's not another number that'll work. So the next one is 5. Plug in a 5. 4 times 5 is 20. And 20 minus 10 is 10. That does not work. Try the next one. 6. 4 times 6 is 24. Minus 10 equals 14, which is not the solution they were looking for. So the correct answer is 4. Let's try another example. We're going to be plugging in -1, -2, and -3 into the equation 9 times w plus 17 equals -1. So we want to plug in -1, -2, and -3 to see which one comes out to be -1. So 9 times -1 makes 9, and since we multiplied different signs, it's -9 plus 17. Remember, if they don't have the same sign, we subtract. So 17 minus 9 makes 8. And we take the sign of the larger. The larger is the positive, so it's positive 8. So that didn't work. Going to try another one. 9 times -2 is -18 plus 17. Different signs, we're going to subtract. So we subtract and get 1. Take the sign of the larger. The larger number is the negative, so it's -1, which was what we were looking for, so that might work. Let's check the next one. 9 times -3 makes -27 plus 17. Again, different signs, so we subtract and we get 10. The larger one is the negative, so it's -10. So the solution is the number that we plugged in that worked, -2. Now let's try the same thing but with some inequalities. They're just a little bit different. So this time the inequality is 2 times s plus 7 less than 13. And I'm going to be plugging in 1, 2, and 3. So the first one is 2 times 1, which is 2, plus 7 makes 9. Well, is 9 less than 13? Yes, it is. So that works. Next one, 2 times 2 is 4. And 4 plus 7 is 11. Is 11 less than 13? Yes, it is. So we have 2 solutions so far. The next one is 2 times 3, which is 6. And 6 plus 7 makes 13. Is 13 less than 13? No. So both 1 and 2 are the solutions. Inequalities can have more than one solution. They can sometimes have a lot of solutions. Let's try the next one. So this time we're plugging in 56, 60, and 64 into r divided by 4 minus 2 is greater than or equal to 13. So the first number I'm plugging in is 56. What is 56 divided by 4? 14. Minus 2 makes 12. Is 12 greater than or equal to 13? No, it is not. So try the next one. 60 divided by 4, that's 15. Minus 2 makes 13. Is 13 greater than or equal to 13? Yes, it is. So that solution works. Then we try the next number, 64. 64 divided by 4 makes 16. Kind of looks like a pattern. 16 minus 2 is 14. And is 14 greater than or equal to 13? Yes, it is. So there's another solution. So both 60 and 64 worked. Okay, so now let's look at the problems you're going to be doing. So you have two problems there where you're going to be plugging in these numbers to see which ones work in this solution. And remember, inequalities like number 2 will have more than one solution. The last two questions, you will be trying to write an equation. An equation. So George wants to buy some movie tickets that cost $8 and a bucket of popcorn soft drink combo that cost $11. He spent a total of $35. So my total is going to be 35, and I need to figure out how to put together the rest of this information into an equation that would go on this side. Once you get the equation set up, then for the next question, you're going to be plugging in these numbers to see which one works and how many tickets George could actually buy.